Hello friends, today we'll go through generative uh, pre-trained transformer, which is GPT, which is an innovation in natural language space. Uh, as you all know, ChatGPT uses deep learning, that is convolution neural networks, which is a subset of machine learning to produce human-like text through transformer neural networks. As you can see on the left side, there is a transformer model, which is from the paper Vaswani and et al. The paper name is Attention is All You Need. You can go through much in detail about the explanations about these diagrams. And this uh, kind of explanations will be going through NanoGPT, which is a repository for training, fine-tuning medium-sized GPTs. This is derived from MinGPT. Uh, it is reproduced from the GPT-2, which is about 124 million params processing. If you have not studied AI or deep learning, then easiest way to train a character level or word level GPT using multitudes of data sets. We'll be using two kinds of data set. One is the Shakespeare's uh, uh, dramas or theaters scripts, and also the million songs data sets from the Spotify. So for training the model, we need a certain set of parameters. As you can see, I have listed context as size. So we have set context size as 256 characters. So if model is able to take an entire conversation into a consideration, it has clearer context. It is able to generate a more meaningful and relevant response. On other hand, if a model is able to load only part of the conversation, that is to essentially finish the regeneration task, it has a short context strategy. Let's consider let's consider in ChatGPT terms. One word is 1.3 tokens, so it is equivalent to almost 1.3 tokens. So initial GPT had context length of 4,000, about 4,000 tokens. That is equivalent to almost like 3,000 words. Anything above the 3,000 words, the model would start to hallucinate and start to generate gibberish uh, response and text. So we can go through much in detail in this particular explanations from OpenAI about what is tokens and how to count them. I'll just list them in somewhere above here. Okay, so let's move on to next part of the parameter, which is number of heads in each layer. We have used six, which is as also as part of the NanoGPT, which we'll be talking about in the next process. So the heads in each layer is number of attention heads for each attention layer in transformer which is basically encoder. So we have three subparameters like query, key, and value parameters, which contains a certain number of ways and passes each split independently through a separate head. And the next parameters is layers. So these are number of hidden layers in the transformer encoder, which is the number of hidden layers within the CNN, that is convolution neural network. And the next part is the feature channels. So if the input uh, has got about 64 channels, the internal output would get around 6 into n, which is the number of output channels. So that would be around 384 channels in total. Uh, So as you can see, we have used NanoGPT repository for training and fine-tuning medium-sized GPTs. The link to GitHub is available here. Uh, so basically, it is developed from Andre Carpati, uh, which is basically is a reproduction of GPT-2 model. You can go through much in detail about this. So let's get started on the implementation. So now, as you can see here, we are in the Nano GPT. Let's go through the NanoGPT details from the GitHub, and you can see the prerequisites that are to be installed, and you have prepare.py, which is basically a tokenization since model understands integers and not characters. We turn raw text into one large stream of integers. We don't have GPU, so we have to make sure that we are using CPU. And next, you can see the once the train.bin and while.bin is generated in data directory. Um, so we'll run this train underscore Shakespeare underscore char dot py, which basically starts training your GPT. We have already discussed different parameters like context size, 384 feature channel, 6 layer transform, 6 heads in each layer, which is defined in the prepare.py Python code. I only have about 32 GB RAM with i7 10 Gen machine. Uh, this is about reproducing GPT-2, and we have if you are more serious in learning about deep learning professionals, you can go through these set of commands, and it only takes about 4 days to kind of train the model and generate the model, GPT-2 model using open dataset, open web dataset. Uh, all the details with reference to the applications are mentioned here. You can go through this in much in detail. So let's get started. So let's clone the GPT, Nano GPT. So we'll use git clone command. Let's execute this. So the cloning is done. Next, next, let's go navigating to the directory in the Nano GPT. Let's go into Nano GPT. Then execute the train.py command with the given set of parameters. Meeting an error for this. Just have to remove the dollar sign there. I don't have the numpy installed. I will have to install the numpy. You can use the pip command to install the numpy. So let's execute now. I have to install request command, so I have to use pip command again. Yeah, so I have installed the pip numpy. I'm still getting an error. Hmm. Yeah, so it's not generating any characters. Yeah, so once you execute the command, basically you will be able to see. So you have to be in NanoGPT folder. So once you execute the prepare.py command, you can see the train dot. If you go into data directory under Shakespeare underscore char, these are the input that is provided as part of training the data. So I'll just uh, stop this. I'm just giving you an example of the scripts that are there. So let me clear the command. So now we have the train data set. So let's execute the training. So I think it will take some time to run about about 2000 iterations. So we'll try to see what's the loss value. So I just stopped at 200 iterations, and as you can see, the loss is around 1.7. That should be it, and you can see the checkpoints getting which got created in out. hyphen Shakespeare underscore jar. So I'm just going to execute the Python sample.py. So okay, I have to be back in NanoGPT. Okay, back in NanoGPT, I have the token that I have to use the pip command to execute. So just use the pip command. Later on, I've just executed Python sample.py. So here I've just make sure you're using the device equal to CPU, and since I don't have the GPU with me. So this is the output which you can see from the sample which I've provided. With every dash dash dash, what you can see is generation of new uh, set of scripts based on the Shakespeare writings and scripts. So that's pretty much the NanoGPT model. I think it works pretty well. You still have to kind of train the model. I've just stopped it at 2000 iterations. So now let's move on to the next part wherein we use the million song dataset. So you can refer to this particular paper from Columbia University researchers have created this dataset from Spotify. Uh, uh, Also, there's a good paper about this, as well as the dataset is available in the one of the website which you can download. There is also dataset available in the Kaggle, so I'm just going to add it here in the chat. So here you can see the Kaggle dataset, which you can download. So there is much description about million song dataset from Spotify, which is about 74 MB, and it's a CSV format, which you can go through much in detail. Uh, so here there is a million song dataset with much more larger dataset if you want to work. So you can go through the descriptions about what all the dataset contains. It could be artist name, details about their scripts and frequencies and MDS and different set of parameters that are available. It also depends on the model which you want to create and train these parameters based on. Um, So as you can see here, you can download the full dataset is about 280 GB. There is also a subset of dataset which is available for 1.8 GB, which you can use it to train your model. So for our scenario, we'll be just using about Spotify million song dataset from CSV, which is from the Spotify, which is available in Kaggle, which you can go through. Now moving on to the next part. So if you open the dataset, you will find the content in the Excel. You will find the content as it is. So you can see the artist, what's the song about, and you can find the complete link which contains the complete song and it also the text of the song, which is the lyrics. Just take a sample if you want. Let me take this above. So here you can see the text which contains the complete lyrics of the song, which you can use it to train. So similarly for the next text, you can also find the lyrics of the song, the artist above. So similarly for kind of different artists, and you can find the for example Olivia Newton. So this is the song lyrics and the yeah. So you can find pretty much many artists with their song name and lyrics. So let's get started. So I've just downloaded the NanoGPT. So I have the prepare.py, which was previously we had configured it to for Shakespeare scripts. There's an input here. So I'm just going to remove the input values. So I'm just going to create a new folder before this in under data called lyrics. So We're just creating one more called prepare dot. I'll just use the prepare.py. I'll just copy the content of this within prepare.py within the data folder. All right, so I have the CSV file here, which you can see. So in the top, the first line where you can notice that there is artist, song, link, and text. Let's moving on to the lyrics. Seems to be loading the data. All right, so under prepare.py, let me just delete the. It's not required to read it from the input.csv. So just let me. I'm going to just delete the content of wherein we are reading the inputs. So we are not reading from the file. So I'm just going to delete this, and then I just have to import pandas. This is because we are reading the CSV file. I just have to delete the request, import request as well. So we are not reading it from there. I have to install pandas, so I have to use pip install pandas. So it will take some time to install the pandas. So while it is doing so, we should be reading the data here from the CSV file. So let's say df equal to pd dot read CSV and the path of the CSV, that is, we have just stored it in the data. So we'll just say Spotify underscore data. Just have to correct the spelling here, Spotify. So yeah, so just write it into df. So data equal to so just this. So what's the column we are going to read? It should be text, right? Is it the first column, right? The artist, song, link, and text. Yeah, we'll just have to copy this text here in the script. So we're reading the text column, and the CSV is this. Okay, so just have to it is separated by new line. So we just have to string concatenate because we have different lines. So we just concatenate based on the different lines. So moving on to the next part is so let's execute now. Python prepare.py. Still error. Strange. It's not able to find the Spotify. It's in the. Let me just add that exact part. Data slash lyrics slash. So that since it is from the NanoGPT, probably it's not able to find that. Okay, I'm just going to call the similar to as the way I called prepare.py. I'm going to call the Spotify uh, then song data.csv. Just wait until this gets executed. Hopefully it should be fine. Yeah. So for time being, I thought it did not execute. So we find that it is trained. The model is trained, and it has about these many tokens, about 22 million tokens, and so forth. So that should be fine. So let's see the directory. So cd dot slash dot lyrics. So here the Spotify, we can see that the train.bin and val.bin is generated. So these are the train models. So here you can see that we are using the encoding of GPT-2, and we have generated exported two bin files. One is train.bit and val.bin. So that should be fine. So now let's want to prepare.py. So here in the prepare.py, we have you can go through the comments which are already added. We have inputs as it is for Shakespeare dataset. The model was basically created for Shakespeare dataset. We just copy the prepare contents as it is, and then we create a prepare sorry train.py and copy the content here. So it's not prepare.py, sorry. It should be train underscore Shakespeare underscore char dot py, which is under the config folder, as you can see here. Uh, there are other set of training and evaluation scripts that are available under the config. So we'll be just focusing on one particular. Before that, let's create. Let's see the train. Yeah, I just copied it from there. So I'm just going to rename it as out hyphen music lyrics for out directory, and the project I'm just going to put it as lyrics, and then that should be it. Dataset is Shakespeare underscore char, so I just have to make sure I'm pointing it to lyrics. So I'll just put it as lyrics. So as you can see, the rest of the inputs are as it is. That's being used for chat GPT. It could be batch size, it could be block size, layers, head, and so forth. So you can go through these configurations for the transformer. So let's keep it as it is. I'm going to save this file later on. So prior to that, let me just create a under config. I'm just going to create a new file. Let's name it as train underscore lyrics. Okay, let's not copy the content of this. Go to train lyrics, paste it here. I don't see the annotations. So I don't see the annotations here. For train underscore lyrics. Okay, I just have to add py. So here we have it. Mm, just again execute the train python dot train.py. So just make sure you have just make sure when you are calling python train.py, so with the train underscore lyrics.py, we are providing a device is equal to CPU. Since I don't have the GPU, in case if you have any GPUs like yeah, AX100 from NVIDIA. You can specify GPU so that the models gets trained using the GPU, and it would be pretty much faster. So here we have it, train underscore lyrics dot py. Okay, it seems to be fine. Let me check it. I have to execute in the nano.gpt. We re-execute from the root folder. Okay, I think it will take some time. Let's wait for some time and see if that gets executed. So here we are. So I think it started the iteration. So the iterations keeps running, and here you can see the loss is about 10.09. That's pretty much unacceptable. So when it reaches certain loss percentage, so it will has a checkpoint so that it stores the model as it is. So let's wait until it gets better. Probably we just have to wait until the iterations are more and loss is reduced. Uh, so I'll skip to the part where the loss is reduced. So I just waited for until iteration 600 around. Probably post that we just have to uh, see that the checkpoint is hit and the model is saved. It's about 600 iterations or so, and as you can see here, I have hit 655 iterations and losses around 3.5. So it's not acceptable, but to some extent, for the sake of demo, I'm just stopping it here. Make sure the checkpoint is hit and the model gets stored. Uh, so here we have out directory start, and so we'll just provide a sample value and then check how the value behaves. So instead of the start, we can override the start. As you can see in the sample.py, we can override these parameters. So I'm just going to say something called strange love to generate the script. Hmm, that's strange. Okay, it's using device type as CUDA, but I don't have the CUDA, so I have to specify uh, the CPU, I believe. Let me try it with CPU. So here it is. So I have used a Python sample.py. So you can specify the output directory. So it's out hyphen Shakespeare hyphen char directory which I've used. So device is CPU and starts with strange love. Let's see if the model gets generated. Seems to be device is CPU. That's fine. So here, okay, it seems that I have used the Shakespeare trained model. I have not used the music lyrics model. So let me just use the music lyrics model. So here you can notice I'm using the output directory is out hyphen music lyrics. So hyphen device is CPU and start with strange love. So previously what you saw was a Shakespeare drama script, theater script trained model. So you could see all the text which was generated based on the input strange love. So I'm now using the music lyrics model. So let's see what it says. So as you can see, it is music lyrics. So we have one. As you can see, there is a one checkpoint created. So here the output. Yeah. So you can see that number of parameters is about 7.2 million, and strange love is what, and you can see the scripts, music lyrics that are generated. So these are some music lyrics. So since that model is not trained to multiple iterations, it's only trained up to 600 iterations or so. So that's pretty good, but it's not perfect. So you could still decrease the loss ratio. Uh, Yeah, you can see different scripts that are music lyric scripts that are generated. So you can use this kind of approach to train your nano GPT models, and it could be anything from your scripts or music scripts or movie scripts and so forth. So it would copy the theme that has been done in those scripts, trained scripts, to generate that. That's about it. Thank you.